So we saw solving these systems by substitution. We can also use elimination. So in a similar idea, you probably want to eliminate, well, actually it doesn't really matter, but usually it's easiest when the coefficient is 1 to start with. So I think I decided to get rid of the x's. So I took the first equation and I eliminated the x's. So I combined it with the first and with the second and the third equation to get rid of the x's. So if I have the first equation and the second equation, in order to get rid of the x's, I multiplied the first equation by 2, the whole first equation by 2, so that way my coefficient is the same, and then I subtracted the whole second equation. So multiplying everything in this first equation by 2 would get us 2x plus 4y plus 2z equals 16. And then we're thinking we're subtracting the whole second equation. So you just have to be careful that you're distributing the negative. So we'll take 2x minus 2x would get us our 0x. 4y minus y would get us 3y. 2z minus negative z means we're adding, so we'd get 3z. And then 16 minus 4 would get us 12. Dividing everything here by 3, we end up with y plus c equals 4. So now we have an equation in one variable. Similarly, we'll look at 1 and 3 together. Luckily, those coefficients for the x's are both 1, so we can just subtract that whole third equation. Again, make sure you're distributing the negative. So x minus x will get us 0x. 2y minus y, y. Z minus 3z is minus 2z. And then 8 minus 7 is 1. So we have the equation, oops, I can erase it, maybe. Y minus 2z equals 1. So now we have two equations in two variables. We can do elimination again. So this time, let's eliminate the y's, since their coefficient is 1. So in this case, now we'll subtract this whole second equation. Again, distributing the negative, so y minus y gets us our 0y. Z minus negative 2z is the same thing as z plus 2z to get 3z. 4 minus 1 would get us 3. So now we know that z is 1. Plug it back into either of these two equations we used here. So I'm going to do the first one. Y plus z, which is 1, is equal to 4, which means that y is 3. Now we take those two values, plug them into any of these three equations up here. So I'm going to pick the top one. X plus 2 times y plus z is equal to 8. So x plus 6 plus 1 equals 8. X is equal to 1. We have all three of our variables. Write our answer as an ordered pair, 1, 3, 1. Elimination here. Again, I look for the coefficient that's 1, so I'm going to use the first equation again. I'm going to solve for the y's. Sorry, I'm going to eliminate the y's. So if I take my first equation, 2x minus y minus 3z equals 1. Start with the second equation, 4x plus 3y plus 2z equals negative 4. So in order to eliminate the y's, I'll need to multiply this top equation by 3 so that my coefficient is the same. And then since this is already a negative y and this would be a positive, we could just add them. So over here, I'm going to distribute that 3, 6x minus 3y minus 9z equals 3, 4x plus 3y plus 2z equals negative 4. Again, since the signs are already opposite, I can just add these. So 6x plus 4x is 10x, negative 9 plus 2z, negative 7z, 3 plus negative 4 is negative 1. So that's going to be my first equation. I'll take equation 1 again, 2x minus y minus 3z equals 1. And now the third equation, negative 3x plus 2y plus 5z equals negative 3. So if I'm eliminating the y's, I'll have to multiply the top equation by 2 to get the coefficient the same. And then again, this y in the first equation is negative, and the second one is positive. So they are already opposites. I will just be able to add. So distributing the 2, 4x minus 2y minus 6z equals 2, negative 3x plus 2y plus 5z equals negative 3. Adding these two equations, 4 minus 3 would just get us x. Negative 2y plus 2y goes away. Negative 6 plus 5z is negative z. And that should be equal to negative 1. So now we have our second equation. Sorry, that should be a 7. 7z equals negative 1. At this point, it doesn't matter which variable I eliminate. So let's go ahead and eliminate the x's. So if we want to eliminate the x's, we'll have to multiply this bottom equation by 10 and then subtract. I'm going to go ahead and just do it in one step here. So 10x minus 10x would be 0x. Negative 7z minus a negative 10z would be negative 7 plus 10z to get 3z. And then negative 1 minus the 10 times negative 1. So negative 1 minus negative 10 would be negative 1 plus 10, which becomes 9. Z is 3. Z is 3. Plug it into one of the other equations. So x minus 3 is negative 1. Add the 3. X is 2. Plug it into one of the equations at the top. 2x minus y minus 3z equals 1. 4 minus y minus 9 equals 1. 4 minus 9 is negative 5. So we add the 5. Negative y equals 6, which means that y is negative 6. Write our answer as an ordered pair, 2, negative 6, 3, and that is our solution.